Hi, my name is Nikita Patil, and welcome to the exploration of robotics. We made the lesson plan for the machines in motion that combines robotics and electronics. I had an opportunity to do the research with Hayden Hanna this summer in ERDEC, where they work on the materials with the robotics, with the help of robots. So this is kind of an inspiration for our lesson. So this lesson is for the high schoolers, and the career they can explore. They can career that will help with them is data engineering, robot engineering, materials engineering, and AI ML engineer. So now to the engagement part. So this is a 45 minutes exploration of how electricity powers robots and how physics dictates their movement. Teachers will introduce the topic with a robot motion video, leading a discussion on observed physics principles, followed by a live demo of basic LED circuit. Student will brainstorm robot navigation and motion measurement, then practice labeling circuit parts and tracing current on diagrams. Formative assessment include group discussions, written reflections, and exit slips on current flow. Adaptation involve using physical props for motion and providing pre-labeled circuit diagrams or Jamboard for digital learners. Now to the exploration.
And hi, I'm Penny Payton. I worked with Nikita while she was doing her research. For the exploration, this is two class periods, about 45 minutes each, or combined if you're doing longer class periods. But the students will basically measure real robot motion using timers and tape measures to understand their velocity and acceleration, and also build circuits and apply Ohm's law. So on the first day, they will more focus on the physics side of capturing activity and measuring that activity, velocity, acceleration, exploring Newton's laws, and the kinematics calculations. Day 2 is more breadboarding and Ohm's law simulations. They will actually look at a short little video to kind of look at a robot and how it moves around, and then perform that for their own exploration and gathering data. Okay, on to the explanation.
So this 45-minute lesson focuses mainly on students interpreting experimental data from both robot motion and electricity. Teachers will guide students in constructing scientific explanation using claim evidence reasoning, which we are going to call now onwards is CER, framework for their motion and circuit data. Students will complete CERs explaining LED circuit behavior and robot velocity changes, annotate diagrams, and engage in peer feedback. This lesson also includes a review of kinetic formulas and Ohm's law, comparing theoretical and observed values. Formative assessments include CER submissions, data analysis worksheets, and peer review. Adaptation include providing sentence starters for CERs and differentiated question test. Now on to the elaborate.
Right. In the elaborate, again, students will be looking at both physics and the electronics knowledge that they have already kind of gained and looked at. Day 1, there'll be more on circuit design challenges and force and motion calculations, just kind of further enhancing what they've already been working on. And day 2, they will actually build and do a test project, again, collecting data from their robots or simulations that they can, and use that information to support their CERs. On to the evaluation.
This 45-minute lesson serves as a capstone where students demonstrate their understanding of robotics, integrating both physics and electronics. Teacher will administer and grade a short quiz covering circuits and motion, access final circuit builds, and collect CR-based reflection reports. Students will complete the quiz, build and or refine their circuits, submit a final claim evidence reasoning report that connects both electrical and motion concepts. Formative assessments include the quiz, a rubric assessed circuit, and a CR reflection on their integrated learning. Adaptation include allowing video explanation for reflections and offering simplified or scaffolded quizzes. So this is our lesson, that electricity motion. So these are the references, where they have these are the references for both electronics and physics, um, that we pulled like we that helped us design this lesson. Thank you.